Welcome to Brain Vision.
To begin the problem, so let's just recall that the differentiability is a local property. Okay, so that's the most crucial point about being differentiable. Okay, so we have the function f of x comma y is equal to y plus sine of x over y, and we are interested in 0, 3. The point is that x over y has a singularity at y is equal to 0, but we are interested in when y is equal to 3. So we observe that x comma y is well defined and differentiable when x comma y belongs to some neighborhood of 0, 3. So we can simply take -1, +1 cross some neighborhood of 3. We can simply take the open interval, say 2, 4. So now we observe that I have the function y plus sine of x over y. So sine is a differentiable function, so the composition of two differentiable function is again differentiable. So y plus sine of x over y is differentiable because it's the composition of two differentiable function. Okay, so next thing we'll be finding the linearization L comma x comma y. So for that, let's evaluate f of 0, 3. So this is going to be 3 plus sine of 0 divided by 3, which is simply 3. Let's compute my delta f delta x at 0, 3. So the derivative of y with respect to x is 0. So the first term is 0. The derivative of sine is simply cosine. So cosine of x divided by y, and the derivative of inside thing, which is simply 1 over y. Okay, and we have to evaluate this at 0, 3. So if I take x is equal to 0 and y is equal to 3, then cosine 0 is simply 1, and then I have 1 over 3, so 1/3. And similarly, we can find delta f delta y at 0, 3. The derivative of y with respect to y is simply 1 plus, again, the derivative of sine is cosine. So cosine of x divided by y, and the derivative of x over y is going to be x y square with negative sign. And again, as before, we have to evaluate this on 0, 3. If I take x is equal to 0 and y is equal to 3, so cosine 0 is 1, so 1 plus, because x is equal to 0 now, so this becomes simply 1. Okay, so finally, so what is my L of x comma y is going to be f of 0, 3 excuse me, plus delta f delta x at 0, 3 times x minus 0 plus delta f delta y at 0, 3 times y minus 3. And we observe that f of 0, 3 is 3. So this is going to be 3. Delta f delta x at 0, 3 was 1/3. So this is going to be 1/3 times x plus, and delta f delta y was 1. So this is going to be 1 times y minus 3. So let me simplify this expression a bit. So excuse me. So this is going to be x plus y minus 3. So 1/3 of x plus y, and 3 cancels, and so that's the linearization.